All right, here we go. Trigonometry review. Now, we are going to use trigonometry in the unit circle. We are going to use trigonometry in the unit circle. But before we get there, we have to understand what trigonometry is. We have to review this stuff because it should be quote-unquote review for you. However, I understand you haven't seen it in a while, so let's kind of review it for a little bit and understand what we're talking about here. Now, what trigonometry is the relationship, the idea between sine, cosine, and tangent. Okay, sine, cosine, and tangent, and we only see it in right triangles. History lesson. What are these three words? Sine, cosine, and tangent. The easiest one, the one that you've seen before and we can actually relate it, would be tangent. So if I have a circle, all right, I'm going to draw a tangent line. Here's my tangent line. It touches my circle in exactly one point. All right, this would be a tangent line. This would be a tangent line, T-A-N, right, tangent. Now, the other two, sine and cosine. This is where it gets very weird. All right, this is very, very weird, and they don't really teach you all out of this in your geometry class, but I feel like they should. So let me kind of back up. All right, now we're talking ancient Sanskrit here. This is thousands of years old. The idea of sine, cosine, tangent is thousands of years old. Where does this word sine come from? Because we don't ever see sine in a circle. Right? And they studied the circle, so they understand what that means. We just never see them. Here's where the word comes from. Sine, or as they knew it as J-Y-A, or ja. Okay, ja in Sanskrit means cord. Okay, sine means, or ja in Sanskrit meant cord. All right. Now, how did that get to sine? Well, when they found the Sanskrit, they said ja, and I wrote it wrong. They said ja, J-Y-A. Get it right, Stitch. Thank you. Ja would translate to jiba. Okay, because what happened was when they were writing down the Sanskrit, right, they would minimalize how much they had to write by not writing consonants. So they didn't write consonants, or it was vowels or consonants, one or the other, and they didn't write it, so they left off of a lot. So if you see J-Y-A, you don't write the A, well, that may be J-I-B-A, or you don't write the Y, right? So things can get left off. You're left with jiba. Then they translated jiba, they changed it a little bit to jaib. Or Google Translate said jaib. And this is Arabic, right? So the Sanskrit is being translated to Arabic, which is jaib. And what does jaib mean? As you can tell, I've done my research. Jaib means cove, or like a lack of space, right? Jaib means cove, or a lack of space, or like a bay, or some sort of area where there's really nothing. Okay? So somehow they got from jaib to jiba to jaib, which means cove. All right. Then in 1150, so this is the year 1150 AD, they translated that to sine. Okay. Jaib, which is Latin, means cove, which is the same thing as sine, or sinus. Okay, S-I-N-U-S, sinus. This is a Latin word. If you know what your sinus is, right, you have your nose, your mouth, that's all your sinus, all that open space in your skull. you refer to as your sinus. That's how they got open space cove, open space sinus. That's how we got the word sine. All right? But at the end of the day, what does it mean? It means cove. It was mistranslated year after year after year over the course of 1,000 years or whatever it is, and sine means chord. Okay, well, let's think about what a chord is. A chord of a circle is nothing but a segment that touches 2 points on the circle. So it's a segment that touches 2 points on the circle. Let's just call it, I missed. Let's just call it this one and that one. There's my quote-unquote chord, quote-unquote, sine. All right. Now, again, this doesn't have to go through the center of the circle, but this is my sine. So we have our tangent line, we have our sine or our chord. What is cosine? Well, cosine is technically it's co dot sine, as in complement complement of sine. Okay, think back to geometry. Complement of a line or a point. Complement means if here's the point I'm given, the complement of that is the blue line here, which gives me the 90-degree angle. Okay, so the complement would be the line that gives it a 90-degree angle. Complement meaning 90 degrees. So the cosine is really the complement of sine. Well, look at my sine. Here's my sine. Let me draw the complement. I may have to extend my circle a little bit. We can do it in purple. So we will do it in green. All right, so here's, and again, I'm not doing this perfectly, but here's my right angle because that is the complement. I have my sine. Now, maybe you see it. If I were to extend this tangent, let me extend this tangent line. And let me extend this complement. Again, it's not perfect because I'm drawing this freehand. But what do I have here? I have a triangle with a 90-degree angle, meaning I have a right triangle. Okay, so why do we only use sine, cosine, tangent on right angles, or right triangles? Because the sine is really the chord, and the cosine is really the complement of that chord, which gives me a right triangle. Now that's a 10-minute rant on sine, cosine, and tangent. A real tangent, if you will, but how does this actually relate to what we are talking about with the unit circle and this whole idea, this whole unit? Well, we do see a lot of right triangles in the unit circle, so we have to review on how do we find the sine, cosine, tangent of these triangles. Well, you may have also heard of this. So, ka. Toa. Right, SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. You see it here. Right, this should be your reference for anything that we do today, tomorrow. This should be your reference. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Everything is color coordinated here. And everything is off of this reference angle, B. Okay? Everything is off of that reference angle. We have opposite, which is in blue here. We have hypotenuse, which is always the largest, or always across from the 90-degree angle, is always your hypotenuse. And then you have your adjacent, which, by the way, is the toughest one to kind of find, but that is always next to your angle. That is always the one that touches your angle. That is not the hypotenuse. That is your adjacent. All right, so here's how we solve this. Let me give you some examples. For each trigonometric ratio, leave your answer as a fraction. Right, so I want to figure out what is sine B. Sine of B, and we have a 3, 4, 5 right triangle here, which is a special right triangle. We have 3, 4, 5 right triangle. I want to know what sine of B is. Well, sine, we know so is opposite over hypotenuse. So if I want to find my opposite, I'm going to start at my reference angle, always circle the reference angle, which is B. Opposite is directly across. Draw your arrow directly across. What do I get? Get 4. Okay, because that is opposite is 4 over hypotenuse. Now, I only have 2 sides left. I have this one, and I have this one. It's tricky, but hypotenuse is always across from the 90-degree angle. So, always across from the 90-degree angle. Here's my 90-degree angle. This would be my hypotenuse, which is 5. Okay, and that's how I leave my answer right now. Sine of B is equal to 4/5. All right, so I know that H is 5. I know that 4 would be opposite in this case. How do I find cosine? Well, cosine is ka. So ka, which is adjacent over hypotenuse. Well, I don't have my adjacent yet, but I have my opposite, I have my hypotenuse, which means that the other one, by default, is your adjacent. So adjacent over hypotenuse would be 3 over, hypotenuse is 5. And then what about tangent? Obviously, TOA. Opposite over adjacent. Opposite is 4. Adjacent is 3. And so I know that my tangent is 4/3. Tangent is 4/3. Okay, and we can leave these as fractions for right now. They're okay. We will see decimals up next. So these are fractions now. These are fine, but these are decimals up next. On the bottom of here, you have everything is the same except for you have a different reference angle. So I'm not talking about B anymore. I'm talking about angle A, which would be this angle right there. All right, so maybe you can do those on your own. And then we're going to keep going on the next page in the next video.